This video presentation is on step-down operation of single-phase to single-phase bridge-type cycloconverter. In step-down operation, output frequency is less than supply frequency, and line or natural commutation in step-down operation is sufficient. The working of single-phase to single-phase bridge-type cycloconverter is simple. To obtain positive output, if positive supply is available, activate thyristors P1 and P2. For negative output, N1 and N2. If supply is negative, positive output is required, fire P3 and P4. For negative output, fire N3 and N4. Let us try to understand how switches are going to be fired, different set of thyristors are going to be fired for obtaining step-down operation. This is a typical input and output for step down operation when output frequency is half of the supply frequency, and this is when output frequency is 1/3 of supply frequency. Again, this is just for representation purpose to understand how we are going to fire different set of thyristors, but this is not the actual output of cycloconverter in step down operation. We can see that to obtain one cycle of output, n cycles of input are required. When output frequency is half of the supply frequency, n is equal to 2. So to obtain one cycle of output, 2 complete cycles of input are required. When f0 is equal to 1/3 of fs, n is equal to 3. Therefore, to obtain one cycle of output, 3 cycles of inputs are required. Next, output will be positive for first n half cycles of input, and for next n half cycles, output will be negative. In this case, n is equal to 2 for first 2 half cycles of input. This is first half cycle, this is second half cycle. So for first 2 half cycles, output is positive, and for next 2 half cycles, output is negative. Similarly here, for 1, 2, 3 half cycles of input, output is positive. Again, output is negative for 1, 2 and 3 half cycles of input. We can also see that output is positive, but supply or the input changes from positive to negative, and it must go back to positive again. So within one half cycle of output, there will be 2 switchings from positive to negative and back to positive again. In this case, there will be 1, 2, 3 changes in input, so there will be 3 switchings. So we can conclude that there will be a switching after every half cycle of input. One half cycle of input is completed, output does not change, supply changes, so there will have to be a switching. Since output does not change, the switching will be between same thyristor groups. So if output was positive, output is still positive, thyristors will be P and P. So switching will occur between P and P group of thyristors. But since input has changed from positive to negative, different set of P group thyristors will be fired. Here P1 and P2 will be fired, and here P3 and P4 will be fired. So to obtain step down operation from a cycloconverter, we have to perform switching every half cycle of input, and that too between different thyristors of the same group, that is from P to P or N to N. So this is what we have to remember. To obtain positive output, positive supply, P1, P2 thyristors. For negative output, positive supply, N1, N2. For positive output, negative supply, P3, P4, and for negative output and negative supply, N3 and N4. And for step down operation, Switching will occur after every half cycle of input between thyristors of same group, and we can understand that for first n half cycles of input, output will be positive. For next n half cycles of input, output will be negative. Let us try to understand this with an example. Let us try to obtain output frequency which is half the supply frequency. So n is equal to 2 in this case. When f0 is equal to 1 by 2 of fs, we consider n is equal to 2. So there will be 2 cycles of input required for 1 cycle of output. So we draw 2 cycles of input. This is one complete cycle, this is second complete cycle. So there are 2 cycles of input. Output will be negative also, so we are also drawing the negative supply Vs. Now to proceed further, we draw a reference output. This is not the actual output of this circuit. This is just for reference that for first n half cycles, in this case for first 2 half cycles, that is 1, this is first half cycle and this is second half cycle of input. So first 2 half cycles of input, output will be positive. Here it is positive. And for next half cycles, next 2 half cycles, output will be negative. So for 1 and 2 half cycles of inputs, output is positive. Again for 1 and 2 half cycles of input, output will be negative. If we consider a firing delay of alpha, okay, first we have to understand that in the first half cycle from 0 to pi radian or 0 to 180 degrees, output required is positive, supply is also positive. From our knowledge of the operation of the circuit, we know that thyristors P1 and P2 must be fired. When P1 and P2 are fired, this is the direction of current, output voltage and current will be positive. Now if we consider a firing delay of angle alpha, the output will look like this. The output will start after a delay of alpha degrees. Output will resemble the input because in this case V0 is equal to plus Vs. We also consider that load is inductive, and when the load is inductive, the output voltage will go a little bit negative. Why? Because the current, load current, will not jump to a high value instantaneously. It will rise to high value gradually after firing at an angle alpha. It will go up to a maximum, then it will gradually reduce as the voltage is also reducing. It will gradually reduce but will not go to 0 at pi radians. It will go to 0 at some angle beta, which is the extinction angle, which is greater than pi. As soon as the current becomes 0, there will be no flow of current, so the output voltage V0 will be 0. So this is the case if the load is inductive and firing angle is alpha, firing delay is alpha. Now remember, in the next half cycle from pi to 2 pi radian or 180 degrees to 360 degrees, output is again positive. Output required is positive because for 2 half cycles of input, we have to obtain positive output. So output required is positive, but the supply is negative. Since the supply is negative, output required is positive, we fire thyristors P3 and P4. As soon as thyristors P3 and P4 are fired, this is the direction of current. Current and voltage will be positive again. But this is discontinuous operation where next firing will occur at angle pi plus alpha, and this pi plus alpha angle is greater than beta. Therefore, from beta degrees to pi plus alpha degrees, there will be no current, because current has already become 0 at beta degrees, and there is no set of thyristors working between beta to pi plus alpha degrees. Therefore, current will be 0 and output voltage will be 0. So when output frequency required is half the supply frequency, n is equal to 2, for there will be two positive pulses of output first, and then two positive pulses of negative are required. So we require now a negative pulse of output. Supply is positive, so we fire for negative output and positive supply with fire thyristors N1 and N2. When we fire thyristors N1 and N2, output voltage and current will be negative. This is how the output voltage will look like. Right? This is reverse of the output. Again, the next half cycle of input from 3 pi to 4 pi radian, we have to obtain negative output. Supply is also negative in this case, so we fire thyristors N3 and 4, and this is the output voltage and current. So this is the complete output voltage and output current of cycloconverter when we are working in step down mode, and output frequency is half the supply frequency, and that too when the mode of operation is discontinuous. Let us try to recall and remember or summarize the operation of cycloconverter. When output frequency is half the supply frequency, we consider n is equal to 2. So we consider n is equal to 2. So when n is equal to 2, there will be two pulses of output which are positive and two pulses of output which are negative. So we will have to obtain two positive pulses, two negative pulses. So when positive pulses are required, thyristor groups P are fired. When negative pulses are required, N group thyristors are fired. In this duration, when two pulses of supply, two positive pulses of output are required, supply becomes positive and negative. So thyristors group between same group thyristors P and P, we have to make a switch from P1 P2 to P3 and P4. Similarly, when negative pulses are required, thyristors group are N, supply is again positive for half of the time and negative for half of the time. So thyristors N1, N2 and N3 and 4 are fired. We can also obtain continuous load current. In that case, pi plus alpha will be equal to beta. So pi plus alpha is equal to beta. So as soon as thyristors P1 and P2 turns off, next set of thyristors P3 and P4 are activated. In that case, output will look like this. Output current is a bit different as from discontinuous current operation. In discontinuous current operation, current rises gradually due to inductive nature of the load, goes to a maximum, drops to 0, and then it stays at 0 because no thyristors are working at that time. So current is discontinuous. In this case, current again rises gradually due to inductive nature of the load, but as before it becomes 0, next set of thyristors are fired, so it rises further to a higher value, and when next set of thyristors are fired, then it goes to 0 and again instantly start rising in the negative direction. Again, before it could become 0, next set of thyristors are fired, so it rises again in the negative direction and becomes higher than the previous negative value. So this is step down operation in continuous current mode. For step down operation, when output frequency is 1/3 of the supply frequency, then n is equal to 3. So there will be 3 positive pulses of output followed by 3 negative pulses of output. For positive pulses, P group thyristors are fired. For negative pulses, N group thyristors are fired. For discontinuous current operation, pi plus alpha will be greater than beta. So this is the output for 1/3 supply frequency. So 1, 2, 3 supply cycles of input are required. There will be first 3 positive pulses of output, then followed by 3 negative pulses of output. As from our previous knowledge, for obtaining a particular type of output, positive for positive supply or positive for negative supply, we know which set of thyristors are to be fired. For continuous current operation, the condition is pi plus alpha is equal to beta. Again, in this case, first 3 cycles will be positive and then first 3 pulses will be negative. Okay, and this is how the current will behave. It will rise to a further higher value and it will rise further again before it becomes 0 and start rising in the negative direction. This is the output of step down cycloconverter when f naught is equal to 1/4 of fs, so n is equal to 4. There will be 4 positive pulses of output, then positive pulses of negative pulses of output. 4 positive pulses of output and 4 negative pulses of output. So thyristors will fire from P1 P2 to P3 P4, P1 P2 to P3 P4, and this is the same operation but in continuous current operation mode. Here pi plus alpha is equal to beta. Hope that this video will help you in understanding the step down operation of a cyclic converter. If you have any queries or questions, you can post that in comment section. Thank you for today. Enjoy the videos on this channel. Thank you.